Hi, welcome to PR Tech Talk. In my two last videos I have showed how to change the ST-Link debugger interface that are default on all Discovery boards, like this one, and all the nuclear boards, to a SEGGER J-Link interface instead. And in my latest video I showed how to do if you have a SEGGER J-Link or J-Link debugger, like this one, and you want to use that instead of the onboard debugger. If this sounds interesting, I have links in the end of this video to those two previous videos. But in this video I will show the main reason I have to use the SEGGER instead of the onboard ST-Link. Some claims that the SEGGER are faster, and this might be true, but the SEGGER also do cost a pretty penny, and the ST-Link is already on board and to a much lower cost, so there are reasons to using both in my eyes. But in my case I already have a J-Link, and this gives me then the possibility to use the SEGGER RTT-Viewer software. Well, what is then RTT-Viewer? It's a software that lets you debug with a Printf style, but on steroids. It's faster than Printf. It doesn't require any hardware ports as serial ports, which is useful on small devices. If you perhaps have only one UART and you need that one to communicate with your target, you don't have an option for Printf, for instance. You can also have output in several terminals. It also enables input from the terminal to your software, so you can have a bidirectional communication. So you can, for instance, in your software halt for an input from the terminal and then proceed depending on what input you get. You can also color the output, for example red for errors or any other combinations or color that you want. It's multi-platform, so you can use it either on Windows, Mac OS or Linux. But you can also use it on different microcontrollers. You don't need to be stuck on STM32, you can use it on various other microcontrollers as well. I will show where to get the software and how to install it. I will add the needed files to Blinky project and also make some demos that will take you to the running start with this tool. I will make all hands-on using my SEGGER J-Link Plus and the Nucleo C031 C6 board. Mainly for this board is a small device, and if it's running on the smallest of STM32, it works on the rest of the boards as well. So I hope this sounds interesting and you are eager as I am to get started. Let's go. So here we are on the SEGGER website, and I will put all the URLs in the description below, so you don't need to remember it now. Here you can see the software documentation pack, and it's free of charge. And you can then select which version. I recommend the latest version, and you will then go for which operating system that you have, and I have the 64-bit installer, so I push that one and just download. Agree and download. Here the file is then on my download files, so you just double click it to install it. So depending on where you installed it, I install it under my C file, my C drive and the program, and then there is a SEGGER folder. You might have installed it in various or other path, I am not sure, but you need to remember where you installed it. So go to that folder where you installed it. There is a folder called J-Link. If we open this one, there is a lot of files, and under this there is something called samples, and under samples there is a folder called RTT. And here is what we are looking for. It's called SEGGER RTT, and it's a compressed file. In my case I just copy that file, that compressed file that we just looked on under my C drive, ST and RTT-Viewer, where I extracted the folder. So this one is the uncompressed folder. So here we have the folders for the RTT-Viewer that we need, and keep these folders close at hand because we're going to use them close shortly. So under the config file, there is one header file that we are going to copy into our Blinky project under include files, and there is also these under this RTT folder, there are these C files that we also would like to have into our C files, in our include files in the project. The files that you need to have included in the include and in the source folder, we find them under the config. There we have one file, it's called SEGGER RTT-conf.h, and that goes into the include file up there. And the rest of the files, sorry, too many, they are in the RTT folder. There are 1, 2, 3 files that we're going to copy over. The S file we don't care about. So the first one, SEGGER RTT, is a C source file. So that one goes into the source file folder. So you have it there. The other SEGGER RTT is a header file. So that one is an H file and it goes into the include folder. And the last file is the SEGGER RTT-Printf.c. So that is a source file and that goes in under the source. So you have it there. That are all the files that we need to include to the project to have SEGGER RTT dependencies installed. So we can now close this folder out. Now we need to make some changes to the main C file as well. I have already done these, so you can see here it's mandatory that you put include segger.rtth as include, and after that there is a file that you need to initialize everything, and I did that in the user begin 2 because then are all the other initializations done in the system. So here is the first real start. So here we put the initialization for the RTT in it. So just copy this file. And also we need to have a buffer because we don't use any UART or any other hardware. So we use a memory area in the memory that the SEGGER is, or the J-Link is looking into. So that is how the communication is done. So we put up a buffer here and we give it a number 0, and the buffer number 0 indicates that you can have more than one buffer. I haven't tested it, and you're free to do so and look into the information online. I will also give you information where you can find that. But in this case we will only use one buffer, and it's buffer 0. Beneath that I also made a small integer, call it x, and declare it with the value 0. That is something that we can have in the printf to increment, so we actually see that there is something happening. So then we can actually start. And if we start with something very simple, and it's SEGGER RTT-Printf, and there you have the buffer for the, you need to declare that one, and so I said it was the buffer 0. So declare 0 again then. And we then print hello world and %d, and that is for the x that I put here. So it starts with 0 and then it's incrementing for each loop. I put then a small delay, and we can also take out this for the moment and just see what's happening here. So if we compile everything, it compiles without any errors or any warnings. And then we can also take a look into the debug configurations, because now I'm working with the SEGGER and not the ST-Link that is default. So then I have changed the debug probe to SEGGER J-Link. Normally it's ST-Link standing there, so you need to change that to SEGGER J-Link if that is what you have. And then we just hit debug. And it's programming the device, and it will change to debug perspective. So we can start running here. But we need to have some output somehow, so we need to rearrange the windows a bit. So you will have to look up this program. Sorry, I can clear all terminals. So there is a folder that or program that you have now installed if you install the files that I indicated for you, and you find it in the SEGGER folder under your installed files, and it's called JLink RTT-Viewer. So open that one and you will get this file open. There is also this file that, or this window that you will be viewed from the very beginning. And I think normally it's with USB there, but if you just hit existing session and auto connect, it will automatically detect your project and tag on that. And there you also see the specific target device. It's found its correct device that I'm running on. And auto detection, and we can just say OK. So it says now RTT-Viewer connected, and if I then hit run here, and there was a breakpoint. Yeah, so now it says hello world 012. And we are now in the folder or the terminal, all terminals. And so I now have only one terminal. So terminal 0 is a default terminal. If you don't have any else, you can have several terminals up here. So we will look into that later on. But now we can see at least that we have some happening here, and we can just break this program to make it a bit more interesting. So we can clear those terminals. We break, and you will see immediately connection lost. So it's waiting for JLink connection now, since we broke the program. And we go back to the main C file, and if we just double click on this one to make it a bit bigger, we can also go down here then to enable this line. And this is saying SEGGER RTT write string, buffer 0 again. And this actually is not a buffer. This is actually which terminal we would like to have it out on. So terminal 0 is the one we are working with. So we can also then change colors that I spoke about earlier. And there are some macros already defined for you, so you don't need to worry about the escape characters. It can be quite tricky. So these are already defined for us. So there is, if you just hover over it, it says macro expression. You see what it actually means or what it translates to. So it's better to have it in real text in my eyes. But you can do whatever you want. If you would like to use it in escape codes, you're free to do so. But in this case, there is the RTT text bright red, and then we change the text. It says this text is red. So it will take the color that we define here. And once we have then printed out this text, we go back to reset, which is then white with black background. So if we now run this one and see if there is any change. Like so. And we can kill the terminals or clear the terminals. There is a way to do that also in software. You don't need it to do it like I did now. But if we run then, you see here in all terminals, you always see these colors. But if we go under terminal 0, then we see hello world is in white, and the red is in red. So that is how you can change different colors. We go back again. And if you're interested in how we can now look in the window in this big and don't look in these folders or here or down here, you can just double click on the folder and it will go back to where it was before, and you can resize everything. But I don't need a Project Explorer or the other folders, so I just would like to maximize the real estate to my main C file. Great, now we have come so far that we have made the hello world with an counter up, and we made a small delay, and we also changed the output to red text and then went back again. Then we can do like this. We can now start looking on more than one terminal. So then there is a command, SEGGER RTT set terminal 1. And as we can see here, there is no terminal 1. You can open a terminal 1 by going up to terminals and increase the terminals when you are running. Now we can't do much since it haven't any connection to the program. But when it's running, you can do that. But I prefer to do it here in the software. So I'm set terminal to 1. That means that from here on, everything is printed in terminal 1 unless I tell it to print it in any other terminal. So then I can make printf just like I did up here. And then in printf I make a clear for the terminal. So instead of going up here and right click and clear it, you can actually do it in software instead, which is quite nifty. And then I printf again, and you see here it's still 0 when I make printf, and it will come out in terminal 1. The reason for this are not the terminal, these are the buffer. So then I put printf and I write the text terminal 1, and I have an X, so I will put 10 plus the X file, so it will be 101, 102, 103 and so forth. And then after that I will set the terminal back to 0. And then it will loop up, so we will have that one in terminal 0, and that one also in terminal 0, and then we will come down to terminal 1 and we will write this one. That is at least the theory. Now we'll see if that is working as well. Still no errors, and that is a good sign. And now let's see if we can. I now put the terminal 0, and we will see what's happening now. So we still have, now we see that it started over on 1, 2, 3, and this text is red. But now we also have a terminal 1. And as you see, it's just incrementing all the time. It doesn't add up here. And why is that? Well, every time it loops, I clear the terminal. So that is the reason for it. I didn't do it here, so that is why it's adding up all the time. And just to make a statement, here you can then close, now it's when it's running. You can't do that when it's offline. So we break it again. So now you can't do anything up here. It's unreachable for us. Great, so we take it a bit further, and we open a terminal 2. And we do like we did on the terminal 1. We start with setting it to terminal 2. And we don't have a terminal 2 up here, so it will be enabled as soon as we run this command. And then we write the text terminal 2 and the 201, etc. So it will be the same as we did up here. Just showing that we have possibility to run several of terminals here. So now we have terminal 0, we have terminal 1, and we have terminal 2. So in terminal 2 we set 204, 205, and terminal 1, 105, 106, and sets. And here we have everything that is written in terminal 0. And here we have all the terminals. Great, so we can go back again. And we can open up the last one. So here we open up the terminal 3. So now we're going to have a lot of terminals. And we won't make clear on this one. So that is the change. So now we will see what's happening when we don't make a clear on it. So now there is a terminal 3 as well. So now you see there's the different behavior. It increases for each loop. But in the terminal 1 and 2, it doesn't. We can also combine various commands in one string, and that is what I'm trying to demonstrate in this line. So here we have the right string, and I have just commented out everything that we just wrote before. And we write string, and the RTT control reset. We make first of all reset, and then we put the text red, and we put it in bright red. So this text will be red, and that won't be. And then we will have back again, and then we have the background bright red, and then reset again, and then the text is normal again. So you can put all this in one string. It's very long, but we will see what's happening. So now we can close all these terminals because we don't use them. I haven't actually learned how to close terminals in software. I don't see the need for it, but if anyone knows how to do it, give us some comments in the chat below. So now everything is closed and everything is cleared, so we can write. So we can stop it there. So in the all terminals it says this is red, this background is red, normal again. This is not quite so, but if we look in terminal 1, we can see all the so red is in normal mode, and then we have this text is red, and the background is red, and then back to normal again, and so forth. So you can actually do a lot in one line. You don't need to have several statements beneath each other. It's up to you what you would like to do. We're done with this video, and hope you find it interesting and you learned something. And if you did, please give it a thumbs up. Make some comments below if you have something that you would like to address. And if you're not a subscriber, please consider to do so. I feel highly appreciated. And if you would like to have a notification when I release a new video, just hit the bell icon as well. It's free of charge, all of it. So if you don't own a SEGGER debugger yourself, but you're willing to or eager to try it on, you can try to change your SEGGER or your ST-Link debugger to a J-Link interface instead. You can just follow these videos that I have here beside me. So until I see you next time, stay safe.